B.tech third year project on tuned mass damper. So how this is working, I will explain the model. This is the mass. Initially it is fixed with the structure. So how where it is, it has application in the skyscrapers. When there is earthquake or any storm is there, so it will give the vibration in the structure. To damp the vibrations, we use this mass. And how it works, suppose it has some vibration due to earthquake, then it will keep on vibrating. You can see that it will keep on vibrating and it will affect the structure. So this mass is initially fixed with the structure and it is not acting as a damper. Now I will make it move it freely from the structure, and now we can see that, you observe it, this structure will have vibration and it got damped. You can see that. So how it works is like, this is a model for the skyscrapers and this is the tuned mass damper, which has some mass and had some length here. So we ensure that how it actually works. Let me show you that. So when we move the structure in this direction, when it gets moved by the vibration of the earthquake or any storm, then this mass has some inertia. It will remain at the same location, and this skyscraper will move in opposite direction. So it opposes the motion. It acts as a restoring torque. Okay. So now it will come here, and we need to move in this opposite direction. Inertia will again oppose. So its inertia will oppose the structure's motion, and it will damp out. In actual structures, there are hydraulic dampers are there which damp out the motion. Here it is getting damped here due to dissipation. And so we will see the by the plot that how it is actually working. So this is the plot. I will show you the plot. So firstly, I will show you when it is fixed with the structure, that is, it is not acting as a tuned mass damper. So I will make it move. I will start it. Okay. Okay. So now we can see here in the screen that the amplitude, you should show both. The amplitude is always maximum due to this vibration. You can see the amplitudes are always maximum. There is no any damping. Now, when we will make this free and act this mass as the tuned mass damper, then it will damp the amplitude. Hence amplitude will get dampened. You can see that. We will see again that how it will be there. So we'll start it, and you can see here, it has maximum amplitude at the start. Now the amplitudes are very smaller. Amplitudes are very small. You can see that, and we can see here that the amplitude of this has got decreased once it got damped here, right? So that's how this tuned mass damper works. How we model it is like that. For any structure, we know that this structure has some omega, some angular, some frequency. So to get the optimum damping, we ensure that the frequency of the skyscraper or any structure should be equal to the frequency of this mass. How we make that? We can vary either mass or this length. Okay, so we can vary the length here by just moving it upward or moving it downwards. So that's how this length will vary. Even we can add more mass on it. So that's how it helps to make it helps to design the omega of this structure. Okay, so that's it. Thank you.